Hi, I'm Keenan Casey for tutsplus.com. In this lesson, we're going to be looking at some of the basic principles and key terms in machine learning. In this video, we'll be looking at these terms and trying to gain an understanding of what they basically mean. First, I'd like us to look at this data set so we can begin to understand it. This data set looks like a table. It's rows and columns. It represents some data about computer geeks, what browser they use, how much they love Legos, their interest in bacon, and whether or not they classify themselves as a geek. So this is our data. Let's connect the machine learning jargon to this data. First term is feature. A feature is a column or an attribute. In this case, we have 4 features: the browser, Lego love, bacon, and geek. Features are columns. They're attributes of instances in our data set. These instances are also called vectors. They're rows, and they represent different examples from our training set, which we may split into a training set and a test set. So in this case, one particular row, Safari 5, extremely interested, and yes, represents one training example or one instance. Lastly, in machine learning, we're going to talk about the target function or the target variable. This is the thing that we are trying to predict. In this data set, we may be trying to predict whether or not a person is a computer geek, this yes/no column, based on the input of browser, Lego love, and bacon. So the target function is the thing we're trying to predict. The most important distinction in machine learning is between supervised learning and unsupervised learning. Supervised learning is basically prediction. When you think about supervised learning, think about the word prediction. In this case, you know what you're looking for, you know what the right answers are, and you're trying to understand this mapping between inputs and outputs, predicting the output based on the input. The two forms this takes is classification and regression. In classification, the output is discrete. It's a yes/no, or it's red, blue, green. In regression, the output is continuous. It could be any number, any real number, for example. So supervised learning is about prediction. Secondly, unsupervised learning, and it's about grouping. In this case, you're unsupervised, and that means you don't know the right answers. You don't know what you're looking for. You're just trying to find patterns in the data. 2 examples of unsupervised learning are clustering and association. Clustering means you're grouping things that are similar together, and association means you're trying to find things that usually go together. First, let's take a look at supervised learning. Recall that supervised learning is about prediction. In supervised learning, we have a set of data which has inputs and outputs. We're going to feed this data into a learning algorithm, and the learning algorithm will output a model. That model represents the mapping from inputs to outputs. Once we have the model, we can put a new input into this model and get some output. Through this process, this supervised learning, we have created a new model which allows us to make new predictions on data that wasn't in the training data set. This is supervised learning. It's all about prediction. Unsupervised learning, we're going to look at in 2 forms. First, clustering. In clustering, we take some set of input, again, training data, put that into a learning algorithm, and what we get out is a set of groupings, often called clusters. So we found that these inputs are similar to each other, and we've grouped them together. These inputs are similar, and these inputs are similar. Another form of unsupervised learning is in association. In association, we have a data set that looks like this, where we have perhaps different patterns in our data set. We feed these patterns into a learning algorithm, and it will determine what kinds of things are associated with each other. So in this example, it appears that the red, blue, and green pattern often appears within these inputs, and also the green, yellow pattern. This is often used in data mining to find items that are frequently bought together. The next thing I'd like to think about is the fundamental trade-off in machine learning. This comes up over and over again, so I wanted to explain it on the front end. There is this trade-off that exists between approximation and generalization. And what I mean by that is approximation is the ability of some model to very precisely approximate the data that we've given it, the training data. Generalization means that the model is able to generalize and make predictions on new data that's not in the training set. And as we'll see, there is this very real trade-off between how well a set of training data can be approximated and how well a model generalizes to new data. The trade-off looks like this. A model may be very good at approximation if it has very low error on the training set, very precisely fits the data, and this works very well. It's easy to accomplish with complex models. However, we'd really like the model to generalize. What that means is we can measure it through having a very low error on the test set. The test set is a set of instances that were not seen by the learning system when it was creating the model. A model that generalizes well may have a less precise fit, but it does better on new instances. And this is actually difficult with complex models because complex models often fit the data too well. And let me give you a visual example of that. Let's consider that we've got these 3 points and we'd like to create a model that represents them. Well, we might simply do that by drawing a line that's as close as possible to those points. This is called linear regression. Now, we have done a pretty good job approximating that, but what if we had a more flexible model, a model that allowed us to, say, be curvier? So what if we instead used this quadratic model? Now we're much closer to our data points. We might ask in this case, given these 2 models, the line and the parabola, which one is the better model? Which one better represents the underlying function? Well, the answer is we really don't have enough information. At this point, it looks like the parabola is the better model. However, if I were to give you 3 additional points, like so, now which one is the better fit? At this point, we'd say, oh, well, the real underlying function looks more linear than that parabola. So although our model was complex and it could fit the data better, that complexity caused it to overfit the data, and the parabola did not generalize well, and actually the linear model fit better, even though it was simpler. Another way of saying this is in terms of overfitting. Overfitting is very much the enemy of machine learning. You'll see this come up a lot. You can see in this diagram how we have this very complex polynomial function in blue that does exactly go through all of the points, but we'd rather have this green function, that's really the target function, the true function that generated the points. In this lesson, we've seen several important foundational principles related to machine learning. First, we've learned what features, instances, and the target function are. Secondly, we've seen the 2 major types of machine learning algorithms. Supervised learning, which includes classification and regression. Supervised learning is all about prediction. Secondly, we've seen unsupervised learning in the form of clustering and association, where both of these are about finding good groupings within a set of data. Lastly, we saw the importance of generalization, creating models that don't overfit the data, but actually fit the underlying model that the data is representing. In this course, we'll be looking at the 2 major types of machine learning. First, we'll look at supervised and talk a lot about classification and regression and see some important algorithms that accomplish these tasks. Next, we'll look at unsupervised learning in the forms of clustering and association analysis and see a few algorithms that implement unsupervised learning. And lastly, we'll finish with some theory and practical matters related to just general advice, tips, tricks, and pitfalls to avoid. I'm Keenan Casey for Tuts Plus. Thanks for watching.